Okay, let me tell you what I did. I went out online and I found a distance time graph. I saved this graph and I looked at it, and I took the data points off the graph and I made a distance time table out of them. So the graph that I took had a time of 0 all the way up to a time of 29. What units, I don't know, it probably, it doesn't really matter here, so we could assume seconds maybe. And what distance units, who knows, maybe meters. I mean, the shape of the graph would be the same either way, but we'll just say it's meters and seconds. Now, what I want to do is I want to look at these points with you, and then I'm going to bring in the graph, and I want to show you if we can predict what the graph's going to look like before we even see it. So let's get started. At a time of 0, what's going on? Well, at a time of 0, the distance is 0. At a time of 1, the distance is 0. That's the same all the way down to 3. So that means that for these first few seconds, the object was sitting still. So just to remind me of that, I'm going to put little red dots in here. Okay? But then after 3 seconds, something happens. The object moves. From 4 to, it looks all the way down to 11 seconds, the time goes up 1 second each time, but the distance goes up 1 meter each time. So from 3 to 4 seconds, we went from 0 to 1 meter. And that pattern continues all the way down to here. So what's going on there? Well, if we're going 1 meter every 1 second, that means right here the speed is 1 meter per second. Sometimes you can get the speed from a distance time table just like that. It's that easy. I'll show you another trick if there's time at the end of this video. Alright, so what happens after 11 seconds? Well, we're stuck at a distance of 8 for a while. So what does that mean? Well, just like at 0, if we're stuck at 8 for a while, that means the object is sitting still. So I'm going to go back to my red dots here just to remind me of that. Okay? Then things get a little different. The distance actually shrinks down to 5. So maybe I kind of lied to you. It's not really a distance time graph, it's actually a displacement time graph. The object is coming back toward home. If you don't know the difference between distance and displacement yet, don't worry, you will. But for right now, let's kind of gloss over that. So anyway, the distance goes from 8 down to 5, so we're coming back home. And this 8 to 5, that's a jump of 3. That's the biggest jump in this whole table, so that means it's pretty fast. I'm going to use a green dot here, and it looks like it jumps down fairly steadily, and then right to there. But now we see that our time keeps marching along, 18, 19, 20, but our distance is stuck at 2 again. What does that mean? That means that the object stopped again for a little while. And then it started up again, and when it started up again, it's still, these distance numbers are getting smaller, so it's coming back home. But these numbers are changing very little. You know, look at this, 2 to 1.7, 1.7 to 1.2. That means that it's moving back home, but it's coming kind of slowly. So I'm going to use this kind of a green color here as these numbers shrink. And then after the numbers finish shrinking, what happens? It's just like the beginning of the graph. It looks like we're sitting still. So what does the graph look like? Well, here it is. Now, based on what we've done, hopefully nothing here surprises us. Let's start with the time of 0 and a distance of 0. So we've got these red dots here, 0, 0, 0, 0 for the first 3 seconds. Well, that corresponds to, whoops, I'm in the wrong color. That corresponds to this part of the graph. So right here, we're sitting still. So when you're sitting still on a distance time graph, the line is flat. And then, what about right here? From 3 seconds all the way up to 11 seconds. Well, that's this part right here. Wish I could turn my highlighter sideways, but I can't. So that's this part of the line. And we already said that in this part of the line, we already knew that the speed was 1 meter per second. We'll talk about that later. Anyway, what happens after that? From 12 to looks like 17 seconds. 16 seconds, I'm sorry, the graph is flat again because the object is sitting still. And then what happened around here in this chunk right here, it went really fast back home, and that's this part right here. Okay, then the object one more time, these numbers stayed the same, and that's where the object was stopped again. And then we noticed that the numbers changed very little, but they kept getting smaller, and that is this spot. And then finally the object was stopped again. Now let's go back to this 1 meter per second. I figured that out just by looking at these numbers here. Every time we went up 1 second, we went 1 meter. Well, that's 1 meter per second. Sometimes it's not that easy, so let me show you this. What I'm going to do is I'm going to take this chunk of line right here and I'm going to turn it into a triangle. I'm going to take the top of this and I'm going to draw the straightest line I can. That's not bad. And I'm going to draw a line, oh, that's kind of bad, right there. So this triangle has distance for its height and it has time for its base. Well, what is speed? Speed is distance over time. So I can figure out the change in distance, divide it by the change in time, and I should get my speed. So what is my change in distance? If I bring this over to the side, I hit at 8 meters. And if I bring this one over to the side, it's 0 meters. So the difference is the final minus the original. 8 minus 0, so that's 8 meters. And then my time is right here, that's 11 seconds. And right there, that's 3 seconds. So what is the difference? The final minus the original? 11 seconds minus 3 seconds, that's 8 seconds. So I've got a distance of 8 meters. And I've got a time of 8 seconds. 8 divided by 8, meters over seconds. I get my speed. And you can do this anywhere that a chunk of distance time graph line is straight. And sometimes if you want to talk about displacement, you can get velocities, you can get negative answers, and so on. But I'm up over 7 minutes, and I think that's good for this video.